We're going to do example 2 with cross sections. So I've already drawn our picture just to save a little bit of sanity. So we want the area bound by the curve y equals the square root of x equals 4, so y equals square root of x equals 4, which is right there, and then the x-axis. So the area that we're talking about is this sort of little curvy shape right here, right? So if we put that, I'll shade that a little bit in blue, right? So there's the shape we're talking about, right? So that is the area, and there are cross sections coming off of that are perpendicular to the y-axis. Now this is the important piece of information: perpendicular to the y-axis, and they're semicircles. So what that means is, instead of going the way they did in the last example, which is this way, my dishes go this way, right? This is the direction my dishes go. And coming off of each one of those dishes, it's a semicircle. So a couple of things are going on here that's a little bit tricky. The first thing that's a little bit tricky is that the bounds I gave you involved x. So this is the bound 0 to 4, but if I'm integrating with respect to y, right, because I said perpendicular to the y-axis, so this is dy, that means I need y bounds, right? So I need the y boundaries. So thankfully, it's easy enough to realize that this is the point 0, 0. So if the x point is 0, so is the y. And similarly, since y is the square root of x, if this spot is x equals 4, it must be where y is 2. So my boundaries are y equals 0 and y equals 2. So that's the first bit, right? The second thing I need to do is find the area of my one dish. Now I know the area of a semicircle in general is 1/2 pi r squared, right? Because semi means half and the area of a circle is pi r squared. So that's fine. But I then need to figure out what r is. So what we've talked about in example 1 was that if you're trying to find a vertical length, you do top minus bottom. But here we don't want a vertical length. We want a horizontal length. I want right minus left. So essentially, to find this entire length, if we look at my semicircle over here, right, to find this entire length, I'll do right minus left. Well, my right curve is where x equals 4, right? So my right curve is where x equals 4. But my left curve, since it currently says y equals the square root of x, is actually where x equals y squared. So this entire length right here, right, this length, my right minus left, is going to be 4 minus a y squared. But that's not the radius. That's actually the diameter. So I get that the diameter is 4 minus y squared, which means the radius is half of that. 1/2 times a 4 minus a y squared. So when I come back up here, my area in terms of y is a 1/2 pi, and then this whole thing squared, which will be a 4th because you square the 1/2, and then this whole quantity, ugly as it is, squared. So that's my formula for area, right? After I find my area formula, my job is going to be to integrate that to find the volume. So my volume is going to be the integral from 0 to 2 of, now if I put this 1/2 times a 4th together, I get an 8th, so I'm going to write that as pi over 8. And then this whole ugly thing squared with respect to y. So this is the actual setup for your integral, right? And if you had a calculator, one option at this moment is to put this in and actually integrate in your calculator. If you chose to do that, right, the thing to be mindful of is it's still always easier to integrate in your calculator with respect to x. Now we're going to do this by hand in a second, but I'm going to admit that it's probably a little bit tedious. So I'm going to show you what I would put in my calculator first. So in my calculator, I'm going to pretend these y's are x's because my calculator doesn't care if a variable is x or y or z or q or t. If it's the integral or the variable of integration, right, it's easiest to call it x. So what I'm going to do in my calculator is I'm probably going to call y1 4 minus x squared, which is totally cheating, right? So this is in the calculator only because y and x are not interchangeable, but my calculator doesn't know which variables I'm using. So I'm going to call this thing 4 minus y squared. I'm going to call that my y1. What that means is what I'm actually integrating is pi over 8 function integrate, right, which is math 9, of my y1 quantity squared, comma, with respect to x, not y, because again, I cheated and used x, from 0 to 2, which are still the y bounds, because again, I know that these x's are actually y's when I put them in my calculator, but my calculator doesn't need to know that. And then I'm going to get an answer, right? So I'm going to get an answer that looks like this, right? Whenever I do this, I'm going to type it in and I'm going to get an answer. One way to see if you're getting the right by hand answer by using your calculator is to cheat and leave the pi over 8 out and make it pi over 8. Get your answer from the calculator without the pi over 8, and then clean up the fraction, right? So that's one way to do this to see if your by hand answer matches your calculator answer. So what we're going to do now is we're going to go ahead and type it in our calculator first, see what answer we get, and then we're going to gut out the by hand option, and that's going to be super duper duper fun. So we are typing in 4 minus x squared into our y1, right? 4 minus x squared into y1, even though I know that it's actually a 4 minus y squared. So I'm going to quit out of that, and then I'm going to hit math 9 to get function integrate. I go to vars, right? So to get y, you go to vars, you go over to y vars, you pick function and 1, which is why y1 is by far the easiest. You're then going to square it, right? Comma is the number, or is right above the 7, with respect to x from 0 to 2. Now notice I left out the pi over 8, right? I left that out because I'm just going to times whatever answer I get by pi over 8. So I hit enter, and I get an ugly number. It's a 17-point stuff. So I'm going to hit math and pick frac, and it's going to give me a fractional answer. So what I get is 256 divided by 15. So super fun, good times. So when I did it by using my calculator, I'm going to get a pi over 8 times a 256 over a 15, which if I clean that up, right, so I'm going to divide that answer by 8 and math frac it, right? If I divide that answer by 8 and math frac it, I get 32/15 with a pi. So I know that if I do all this work myself, I should get a 32 pi over 15, right? And that's fine. Now we're going to gut it out by hand, and I'm going to erase a lot of the work that I did here so that I have some room to do that. So if I clean up this space a little bit, so we don't need all of this anymore because it's a video, so you can go back if you need it. All right, so let's go ahead and find our volume by hand. We know that our end goal is that 32/15 times pi. So I'm going to yank the pi over 8 out, right? I'm integrating from 0 to 2. And I'm going to go ahead and FOIL out and get 16, right, because it's 4 times 4, minus 8y squared plus a y to the 4th with respect to y. Again, the pi over 8 sitting in front is probably the best case scenario. So I get 16y minus 8/3 y cubed plus y to the 5th over 5. And you can see how I'm going to land with the 15 at the end because you see that my fractions already have 3s and 5s. So I have this pi over 8 sitting out in front. And then when I plug in the 2, I'm going to get a 32 minus 8 times 8, which is a 64/3, right, plus a 32/5 minus what thankfully comes out to be a bunch of zeros. 0 minus 0 plus 0, great, don't care, it's a bunch of 0. I happen to notice a GCF of 32, which is going to make my life way easier. So I'm going to yank out a 32 to go with this pi over 8. And what happens is I get a 1 minus 2/3 plus a 1/5, and those are much easier fractions to work with. You don't have to see that, but boy does it make life better. So out in front, this is now a 4 pi, because the 32 over 8. And then I'm going to make my common denominator 15s on the inside. So this is a 15/15. When I times the 2/3 by 5s, 5 over 5, I'm going to get a minus 10, right? And when I times the 1/5 by 3s to make it a 15, on the bottom, I'm going to get a 3 all over a 15, right? So what seems to happen is I end up with 15 minus 10, which is 5, plus a 3, which is an 8. So I get 4 pi times 8 over 15, which is absolutely that 32 pi over 15 that I was looking for, right? This is not an unreasonable problem to be asked to do by hand, but it's very smart to know how to do it in a calculator. We get the same answer either way.